Today we're going to be talking about the fundamental theorem of similarity. We're just going to go through a couple more examples here dealing with our theorem, just to give you a little bit more kind of notes here before you start on the other worksheet for today. So, just a quick review of the fundamental theorem of similarity. It says that if we have two figures that are similar, so if we have a figure g and g prime that are similar, then we know three things. Their lengths are going to be similar based on just a single k value. Their areas are going to be similar based on k squared, and their volume will be similar based on k to the third, or k cubed. Okay, which again, the quick little hint that I gave you was that the power on the k is the same as the unit. So if we're regular units, we're in lengths. If we're in square units, we're talking about areas. It's k squared. Volumes are cubic units, or k to the third. Okay, let's go ahead and jump into this first problem here. We have one square has a side length of 5, another has a side length of 12. We want to know how their areas compare. So to start here, I got to figure out a k value. I've got to figure out what kind of k value I have to work with, and then what kind of k value I'm trying to get to. Okay, so to start here, I'm working with a side length and a side length. So when I compare those are just lengths and lengths. That is going to be just a regular k value. And now I'm trying to compare their areas. So I'm going to take that and I'm going to try to go to a k squared value. So from k, I need to go ahead and start to divide these things. Now, we don't have any more information here about what we're trying to do with this, so it doesn't actually matter what direction we divide this. Typically, if we don't know the direction, I'll put the bigger number on top, just in case it might work out to a nice whole number for us. So 12 over 5 is reduced. We can't do anything else with that, so this one we are kind of stuck with that. But I do need to go ahead and take that 12 over 5 and raise it to the second power. And when we square a fraction like this, we square both the top and the bottom. So we're going to square the 12, gives you a 144, and 5 squared gives us 25. Right, this is going to be one of our answers, okay, for how those areas would compare. The other one is going to be the same numbers, but the reciprocal of that original fraction, or just flipping that fraction. Okay, these are going to be how our two areas are going to be compared. So one is going to be 1 over 444 25ths bigger than the other, or 25 144ths smaller. So those are kind of our comparisons that we're going to use. Okay, number 2, we're going to start with two similar airplanes. So these are models of airplanes, not actual airplanes, so they're both relatively small. But the larger model of the two is going to be 180 centimeters long. The smaller one is going to be 90 centimeters long. So there's going to be our comparison that we're going to use. We want to know how their wingspans compare. So wingspans on an airplane are kind of tip of the wing to tip of the wing. So that is just a straight line measurement, which is just a regular length. So this is going to be based on just a regular k value. So I need to go ahead and find that k. Now again, they don't tell us what direction we're necessarily going. We're not going to try and use these k values for anything, so I can really do it either direction. I'll go ahead and start with the bigger one on top over the smaller one. So I'm going to call it 180 over 90. If I go ahead and divide that, 180 divided by 90 is 2. So that is my first answer. Or I can go ahead and flip that into a fraction, because this is really 2 over 1. They could also compare as 1/2. Okay, so the lengths are going to be either twice or half, depending on which direction you're going. Okay, we can also do the same thing with areas. Okay, we're talking about the area of the tailpiece, so just the tail fin kind of on the airplane. Now, because we're talking about areas, we know based on the fundamental theorem of similarity that that then means I need a k squared value. Now, because I've already found the k value up in part A, I don't necessarily have to do the fraction and reduce again. I can just use these two fractions. So I'm going to start with the 2. I can go ahead and square that. 2 squared is 4. So that is my first answer. Or I can go ahead and make that into a fraction as well, just like the 1/2, to give us a 1/4. Okay, now let's talk about weights. So weight is a measurement that is not necessarily directly related to the lengths, the areas, or the volumes, but it does follow very closely with volume, which should make sense. The heavier something is, the more there should be of that thing. Now we do have to kind of take into consideration what it's made of, making sure that we're comparing things that are made of similar things. We don't want to compare a giant airplane that's made out of metal versus a model that's made out of foam. Okay, those weights are then going to have other things involved. But as long as we're using the same materials, which these are both models, so we can assume that they're made out of the same thing, we are free to compare them using those volumes. So weight here is going to really refer to volume. which means we need k cubed. And again, I already have k from part A, so I'm going to go ahead and take that 2 and raise it to the third power. 2 to the third power is 8, or we can go ahead and write that as a fraction again as 1/8. So we have 8 or 1/8. Okay, and for these first two, I didn't ask you to find any pieces from here. I could very easily ask you to do that. I could tell you the wingspan of the bigger model was, I don't know, 80 centimeters, and then you could then find the wingspan for the smaller one. Okay, I didn't ask you to do that. We're more talking about these k values because that's the new piece. You've done the finding the missing pieces a lot at this point. Okay, let's talk about number 3. So we have similar pyramids here. And 2 corresponding edges of those pyramids are 8 inches and 12 inches. Okay? Part A is asking us to find the volume of the larger pyramid if the smaller one has a volume of 100 cubic inches. Okay? So we have these 2 straight line measurements at the top here. We're going to use those to find our k value. So off to the side here, I'm just going to quickly find k. I don't know which way I want to divide this yet, so I'm going to go ahead and do just the 12/8. And see if that's what's going to work for me. If not, we can always flip it around later. Okay, this would be the same thing as 3/2 if I go ahead and reduce that. So I'm going to call my k value 3/2. Okay, now for part A, if I am talking about volume here, that means I need a k cubed value. Okay, for k cubed, I then need to take this k value and cube it. Now I do want to make sure that it is set up in the correct way. So I did the 12 on top and the 8 on the bottom. Based on what we talked about in our notes yesterday, we're going to say that the one we know more about goes to the bottom, the one we know less about goes to the top. So if the volume of the smaller one is 100, that's more information about the smaller measurement, which is 8. So I want to keep that on the bottom, the 12 will stay on top. So the 3/2 is the direction I want this, but I still need to cube it. Okay, so we'll go ahead and find that 3/2 cubed. 3 cubed is 27, 2 cubed is 8. So it's going to be 27/8. And then we're free to multiply that by the volume that we already know, which is the 100. If I multiply that all the way through, I should get roughly 337.5 inches cubed, or cubic inches. Okay, so this here is our answer. Okay, now for part B, it looks very similar, but we want to find the volume of the smaller pyramid if the larger one has a volume of 100. So we're still using the same volume, but now I'm telling you that that's the larger one, so I need to make this thing smaller. Now, my k value that I was using here was 27/8. That's bigger than 1, so it's going to make my volume go up, which it did. However, because I'm starting with the larger volume, I really need it to go down. So I actually need to change my k value here. And this is where I now know more about the larger one, so I want the 12 from my k to be in the bottom and the 8 to be on the top. Now, what that's really going to do is just flip these 2 pieces around, and the 2 and the 3 are going to flip as well. So now k cubed is going to be 2/3 to the third power. Or I can flip my 8/27, or flip to get my 8/27. And then again, go ahead and multiply by the 100. If I go ahead and multiply that all the way through, we get 29.63 inches cubed. And that one, I believe, was rounded a little bit, but very close. Okay. Part A, we are looking, number 4. We are looking at a scale model that is 1/15 the actual size and is made up of the same materials as the original object. We want to know how will their weights compare. So again, weight is important that we did say same materials here. That is something that we will need. But weight here is going to be based on volume. Okay? And we can make that assumption as long as we're using the same materials. Okay? Because we're using volume, I need to know k to the third. Now, they're actually giving you the 1/15 here. That is k. That is your scale model, your scale factor, your k value, your magnitude, your ratio of similitude, whatever you want to call it, that's the same piece. Okay, so we want to go ahead and take that cubed value on the 1/15. So this is 1/15 to the third, okay, which 1 to the third is still just 1. 15 over to the third is 3,375. So our answer here on the blank is going to be 1/3,375. Or just for the sake of knowing what it is, if you want to divide it out, it is 0.000296. So a very, very small k value. Okay, but if we're talking 1/15, that means every 15 inches is becoming 1 inch. That is a significantly smaller model than the original object. Okay, let's talk about part B. We're talking about the amount of paint needed to cover the exterior of whatever object that we're working with. Okay, now painting the exterior is going to be directly related to the surface area of that object. Now surface area does fall into the area group of things, so we need to find k squared. And just like before, our k value is still starting with 1 over 15, so we're going to go ahead and square that. If we go ahead and square that, we get 1 over 225, which is our answer here on the line. And again, if you want to go to the decimal, just to kind of see what it is 0.0044 for that 1 over 225. Okay, and then the last one here down at the very bottom, let's talk about pizza again. We have a pizza store manager is calculating the ingredients for a 16-inch pizza. Cost the store $1.50. At this rate, what do the ingredients of a 12-inch pizza cost? So this is not the cost that someone's going to pay for it. This is just the cost of what all the ingredients are going to charge the store. Okay, so let's go ahead and see if we can get this thing set up. So again, I need to take my pieces that correspond, which here's going to be the diameter of those pizzas, that 12-inch and 16-inch, and I need to set those up into a fraction. That's going to get me just a regular k value because these are just straight line distances. So I'm going to find k by using that 12 and 16. Now, to figure out which one goes where, I got to figure out what I'm trying to do. I'm trying to find the cost for the 12-inch. So that's the one I know less about. I know more about the 16 because I know the price for that one, or the cost for that. So the 16, I'm going to go ahead and throw it to the bottom. The 12 will go on the top. Hey, I can reduce that fraction. 4 goes into both of those. Goes into 12 3 times and 16 4 times. So that's the same as 3 over 4. Okay, now, we talked about this in your notes yesterday. Just a regular pizza is going to be based on area because we can more or less ignore the thickness of the crust. Okay, we're really just talking about what's the area we need to cover with all these ingredients. If this was a deep dish pizza, because we have the thickness then in the ingredients as well, then we have to talk about volume. But because this is a regular one, I need to go to k squared. So I'm going to go ahead and take my 3 over 4, and I want to square it. Okay, if I square 3, I get a 9. Square 4, I get 16. So this is 9 over 16. Then I want to go ahead and just multiply by that 12-inch pizza. If I go ahead and multiply that all the way through, I get 1.125, which is technically the correct answer, but because this is money, we'll go ahead and round to that second decimal place, and we'll call it $1.13. So this is your answer for number 5. Hopefully that kind of clears up any last little questions dealing with the fundamental theorem of similarity. If not, make sure we are asking questions, and we will go from there.